Hello everyone, I'm Sai Sushmita Anavulu. My final IoT project is real-time motion tracking system. Let's see the introduction. Motion tracking generally tracks the movement of objects and transfers the sensor data to an application for further processing. It can be expanded to tracking the movement of humans and their gestures too. It is widely applied in military, entertainment, sports, medical, validation of computer vision, and robotics fields. In smart building domain, motion tracking system can be used to detect the fall of an object and intrusions at home or any commercial building with proper implementation. The purpose of the prototype sensor system is to detect the parameters and shares it to users through MQTT for motion tracking. Components. The devices used in this project are MPU6050 accelerometer and gyroscope sensor, ESP32 development module, and a laptop. IoT platform is connected over Wi-Fi and it has Mosquitto MQTT broker, Node-RED as a coordinator, MySQL database, which are all running on localhost. For the web server, I use HTTP Grafana web server, which is running on localhost as well. Process specification. MPU6050 sensor is responsible for capturing the sensor data. ESP32, which is connected to this sensor, publishes the data via MQTT. Node-RED coordinator receives this published data and then stores the data in MySQL DB using Node-RED flows. Later, HTTP server queries the DB data for motion tracking. Here is the overall enterprise architecture. In the devices, we can see the sensor is being connected to ESP32, and there is a publish and subscribe connection between ESP32 and MQTT broker. And in the same way, the similar connection is there between the MQTT broker and the Node-RED coordinator. There is a connection between database and Node-RED. We establish this connection using the MySQL node in Node-RED, and we write, which is nothing but we insert the data into the database using the function node of the Node-RED flow. In the web server, which is Grafana web server in this case, pulls the data from the database for motion tracking by metric analysis and visualization. Service specification. Input to this project is nothing but the acceleration and gyroscope readings which are obtained by the MPU6050 sensor. Output is nothing but motion tracking on a web application. Services like Node-RED, HTTP server, and MySQL web services are there for analyzing and visualizing the data. ESP32 development module, Node-RED, and MySQL database and web servers are the endpoints of this project. Functional perspective. In the application layer, we have HTTP server and MySQL server, and there are multiple managements in the management layer. MQTT offers a publish and subscribe service, and we have a data visualization service offered by the HTTP server. MQTT, Node-RED, and 802.11 medium serves as a communication in this project. And for the security control, there is an authorization and authentication, which is done in MySQL database and web application. For the devices, we have ESP32, a sensor, and a laptop. Let's see the device and component integration. We have ESP32, which is connected to a MPU6050 sensor. We connect the VCC to 3 voltage, and then we connect the ground to the ground of the ESP32. The serial clock of MPU is connected to 22 pin of ESP32, and the serial data pin of MPU is connected to 21 pin of ESP32. From here on, we'll see the programming and live execution of the project. The programming for this project is done in Arduino IDE. The Wi-Fi library is used to establish connection to a Wi-Fi router, and PubSub client library is used to establish connection between ESP32 and MQTT broker. The libraries I2C Dev and MPU6050 are used to interact with the sensor. Initially, we try to initialize the accelerometer and gyroscope variables. Now we have to set up the Wi-Fi connection and MQTT broker connection. For the Wi-Fi connection, we specified the SSID and password of the Wi-Fi router over here. And for the MQTT broker connection, we have specified the MQTT server address, which is nothing but the IP address of the system over here. Initially, we try to set up the Wi-Fi connection. Once the Wi-Fi connection is done, then we try to connect to MQTT broker. Once the MQTT broker is connected, we then read the data and then publish the sensor data to MQTT broker. Some of the challenges I faced and solved are: if your ESP32 dev port can't be recognized by Arduino, then download the CP210 universal driver from the internet and update the driver in the device manager of your system. Then you can be able to see the port in Arduino. If your MQTT connection is failing with RC-2, then turn off all your firewall protection on your laptop and set the listener port to 1883 and anonymous access to be true in MQTT configuration file. Then you will be successfully connected to the broker. Now let's see the Node-RED flow. The nodes used are 6 of the MQTT input nodes, a join node, a function node, a MySQL node, and 3 of debug nodes for debugging purpose. Let's see the configuration of MQTT input node. We have specified the client ID, the server address, and the port number on which the MQTT is listening. In addition, we have specified the topic name corresponding to each message. A join node is used to combine all the message payloads of MQTT input node into a single message created as a key value object. These key names are used in the function node to insert the data into a database. As I said earlier, we have an insert query in the function node to insert the accelerometer and gyroscope readings into the table of our database. MySQL node here is used to connect to a MySQL server. We have specified the server address, port number of the MySQL, username and password, and the database on which our data need to be stored. On the whole, MQTT broker input node subscribes to all the messages, which is then joined by the join node into a single message, which is then inserted into a database by the function node. For the demo presentation, I have connected the ESP32 development module with MPU 6050 sensor. We can see the accelerometer and gyroscope readings in the serial monitor of Arduino IDE. The values remain almost same because the sensor is still. Now I'll try to move the sensor and let's see if there is any. I'm moving the sensor rapidly and let's see the changes in the readings. As you can see, there is a change in the readings. The numerical value of the accelerometer and gyroscope readings have been hiked. I moved the sensor for quite some time, so as you can see there is a change, and I kept it again in the resting state and the values are back to normal again. Let's see how the values are being captured in the Node-RED. So this is the key value pair that is being created by the join node, and with these key values the data is being inserted into the MotionDB. Now let's go to the Grafana web server. This is the Grafana web server. I've created a dashboard. In this dashboard I'm trying to track the motion. So this is the previous motion captured. Let me see and let me run the query and see the motion that is captured right now can be seen in the web application or not. So I have created a SQL query over here. And running it. As you can see, There's been a change in the readings since the sensor is being moved, and that can be clearly seen